Okay, so this time we're going to build a sampling distribution out of the same data that's coming from the NOAA Scripps Institute with the CO2 data measured in the atmosphere at the Mauna Loa and other observatories. And it shows us in the monthly average of the CO2 measuring. So to build a sampling distribution, we're basically going to random a whole bunch of random samples from the CO2 data. And what we're going to do is we're going to assume that the data set that we have represents the population, because actually it is all of the measurements, at least at this sampling stations, of the atmospheric CO2 in the atmosphere. And what we're going to do is we're going to make a whole bunch of samples. So let's start with 10,000 and see what happens. And using these 10,000 samples, we're going to calculate the mean and then represent that graphically so we can have a graphical representation of the sampling distribution. And we can also show this way a 95% confidence interval, which means we can show the interval within which we have 95% of the sample means that are falling in the distribution. So if you want to know how to read and inspect the data, you can go back to the previous video. Here I'm just going to re-inspect the data. So it's a data frame that we created earlier that we called CO2_data with 780 rows, 8 columns. And when we show the first few rows using the head function here, we can see the first 6 rows of the data. You can see we have year, month, the date in a decimal format, the average, and then a few other things that we don't have to care about right now. We can save nrows as our population side, and then we can calculate the mean using the mean function, the mean overall over the 1958 to basically almost right now, of the monthly average of CO2, we use the mean function on the vector on the column average, which has the average CO2 concentration each month. And we store that into an object called mean CO2. And then we can show it on the screen by just calling the object. And we can see we have 357.9.9017. Now we can start to prepare the repeating loop to build the sampling distribution. So first, we need to initialize or to generate a number of empty objects. So one that I'm going to call temporary sample, that's where we're going to store the data every time we generate a random sample. And then one that I'm going to call results 10, just calling it results 10 because I plan on taking a sample size of 10, and we want to generate an empty object that will be able to retain that data. That's a vector, by the way. Both temporary samples and results are vector. We're also going to be calculating the sampling distribution. And actually here I'm putting vector, but it doesn't have to be a vector because it's just going to contain the mean of the sampling distribution. For example, I can just put the number 1 completely arbitrarily in there. And then we have a step counter for the for repeating loop that we call I, and it's just going to receive for now the value 1. And another thing is we want to make sure that we have no graphical device open, so I'm going to run dev off a couple of times. That closes any graphical device. At least I executed once that it said null device 1, so that means there is at least one other graphics device that's, that was one graphics device that will open at the minimum. And then I executed a second time, it says cannot shut down graphics device, which allows me to know that for sure there is no other graphics device opened. Then I'm going to split the graphical window or the graphics device into 2 rows and 1 column because I want to stack together 2 histograms, one that will show the current random sample and one that shows the sampling distribution as the repetition of the 10,000 samples are being computed by the computer. And so every time it makes a new repetition, it's going to show a new sampling distribution and as well a the current sample that it has just added to the sampling distribution. And then we'll do 10,000 repeat with a sample of size 10, and we're gonna calculate. We're going to take the random sample, store it into temporary sample, then calculate the mean of that temporary sample, store it in the results 10 that we created earlier at the position I. I is again the step counter, so it's going to have the value 1 the first time around, then 2, and so on and so forth, up to 10,000. And then we're going to calculate the mean of the sampling distribution to store it into the mean sampling distribution object. And then what we can do also is we can add the mean of the sample, so the location of the mean on our histograms, and we could also add the mean of the sampling distribution on the histogram to see what happens over time. So this is our repeating loop here. There's another thing that I'm adding here is a couple of stops where I'm asking the computer to pause for a fraction of a second, well, a quarter of a second here to be more precise. So we have time, our eyes have time to see what's going on. So this first line here tells the computer you're going to repeat this 10,000 times. Then you're going to pause for a quarter of a second. Then you take a random sample from the object that contains the average monthly CO2 concentration, a sample of size 10, and you don't replace it. Meaning when you pull the first individual of that sample, you don't place it back, so each individual of the sample doesn't have a chance to be picked again within one given sample. Then I calculate the mean of the sample and store it into the results 10 at the position I, which means the first time around it goes in the first position, second time in the second position, and so on. Then we are going to calculate the sample mean, and to do that here, since we already calculated the sample mean, because we calculated it to store it into results 10, so I'm just putting it in there. But just to make sure, I want to, since I know that it's in the 3 to 400, and I want just one significant digits, I'm going to use the signif function that basically rounds the value to several, 300 something period, and then just one significant figure, one decimal after that. And it's going to store it into the object sample mean. And then I calculate the mean of the sampling distribution. Here, same thing, I'm going to round it, so there's only one significant figure. And then finally, not finally yet, but I'm going to draw a first histogram of the temporary sample. So I'm, choosing a light blue color to have a label on the X and the Y axis with bin size of 25 between 300 and 425 with a certain title. And I'm going to also add here in the title, by the way, I'm saying I want to put together the phrase or the string of characters CO2 ppm, comma, n equals 10. And then I want to also add mean, and then I, the counter. So it tells us that's the mean of the sample number I, right, equals, and then also shows the mean of that given sample. Then I want to add a line that shows the value of that mean. So I put results 10 equals high, but actually, since I stored it into sample mean, I can just call that object right here. So we kind of simplify a little bit the code here, and there's not I appearing too many places. And then I'm just saying I want the line in that vertical line to be dashed, and then LDW, that's just the size, the thickness of that line. Then I'm taking another break, so my eye has time to look at the first graph. And then I want to stack below that a second graph or second histogram. This time I'm showing a histogram of results 10. So that's the sampling distribution. So the first time around, by the way, there's only going to be one mean. Same thing, I put a title and so on and so forth. Also, I'm going to add both the mean of the current sample and then the mean of the sampling distribution. This time here for the sampling distribution, the mean of the sampling distribution, I want a dotted line and a different color. That's why I put dotted in LTY, and magenta, which is a pink color, in COL. And then another break, and then we're done with the repeating loop. So now that bracket here mark the end of the repeating loop. If you didn't notice, at the beginning of the repeating loop, what we see here is the opening of that bracket. So now I close it and pay attention right here to the graphics device, what's going to happen as soon as I execute this. And now we can see it's taking a random sample, showing us how many samples have been taken so far. The mean shows the sample, adds the line corresponding to the mean of that sample, and below we have the sampling distribution. So for now, there is only 16 samples, right? Calculates the mean of the sampling distribution and shows both the mean of the sampling distribution and the mean of the current sample. And so what you can see is that the mean of the sampling distribution, even just with 30 samples, it's already pretty stable. It doesn't budge too much. It was at 360 something earlier, now it's at 358, while the mean of each sample varies quite a lot between 340 and 380 something. And so this just shows how the repeating loop works. So now I'm not going to let it run like this for 10,000 samples, otherwise it's going to take way too long. So we're going to